Congruence in ASA, angle, side, angle. So if you could demonstrate that you could find an angle of one triangle congruent to the angle of another triangle, and that a side of one triangle is congruent to the side of the other triangle, and that another angle is congruent from one triangle and the other triangle, and that the side that you mentioned is between, this is important, that the side you mentioned is between these two angles, you could use this as a shortcut to prove congruency. So we have these two triangles, and notice they have two angles that are equal, so that's these two angles. And they have two sides, but the two sides are not between the two angles mentioned. So at this point, you cannot use ASA. So what you do is try to bring more information. Notice we have angle, angle, but the side is on the outside. Angle, angle, but the side is not between them. So you can't use ASA. So bring some more information. Let's see if we can get an ASA going. Since the sum of the three angles in each triangle is 180, you can figure out the missing angle. So the three have to equal to 180. So you can figure out the other angles. Now we have all three angles available. Now, notice these two angles equal these two angles, and the side between them are also equal. So it's ASA, ASA. Now you could say the two triangles are congruent by ASA. Here's one more shortcut to prove congruency, AAS. In this case, you could have the two angles and the side not between them being equal between the two triangles. So angle, angle, side. So this is not included. Not included means it's not in between. If it was included, then the side would be in between. So this looks kind of congested, so break it up. This figure is made up of these two triangles, and I'll start seeing what you have. So you label them. Notice we have angle, angle, side, angle, angle, side, and this side is not between the two angles that was mentioned. So angle, angle, side. The side was not between the two angles mentioned, so you could use AAS. So these two triangles are congruent by AAS. This one, we're going to concentrate on diagonals. Remember, a diagonal goes from a vertex to the opposite vertex. So vertex to the opposite vertex. This is a diagonal. Here's another diagonal. This is an isosceles trapezoid because the legs are congruent. That automatically makes these base angles congruent, by the way. So diagonals are congruent for an isosceles trapezoid. That means this diagonal measures what this diagonal measures. Now we're looking at a parallelogram. Remember a parallelogram, these little arrows here, one little arrow here, one little arrow here means these two are parallel. Two arrows here, two arrows here, that means these are parallel. For a parallelogram, diagonals bisect each other. So notice this diagonal cut this diagonal in half and vice versa. But we don't know if all the halves are equal. We just know that one diagonal cut the other one in half and the other one cut the other one in half. But we just know that these halves are equal and these two halves are equal. For a rectangle, diagonals are congruent and bisect each other. So in this case, they're doing what the previous one was doing. They're bisecting each other. But since the diagonals are congruent, they have equal measurement, all the halves are going to be equal this time. For a rhombus, diagonals are perpendicular and bisect each other. So again, they bisect each other, but we don't know, they're not saying that diagonals are congruent, they're just saying that they bisect each other. So we know these two halves are equal, these two halves are equal. And on top of that, they're perpendicular to each other. That's what's unique about a rhombus. For a square, well, it has the properties of parallelogram, rectangle, and rhombus. So what we said about those diagonals, parallelogram, rectangle, and rhombus, what we said about those diagonals, the square has all those qualities.